My name is Chloe Miller, and I'll be going over lab number 1, amount of excess charge on an ordinary object. In this case, we used a piece of tape. For the introduction, we discovered the purpose of the experiment was to determine the excess charge on a piece of charged tape. As we've learned in lecture thus far, charges can be determined by interacting with other items of charge. And the main idea is to provide an understanding of how charges interact with one another in a form of real-world application. So we used a piece of tape that we were not sure of the charge, and we compared interactions with other household items that we did know the charge of. For the actual experiment, we made U-tapes, which are charged pieces of tape that are made from the adhesion of other pieces of tape, and viewing how it reacted with other household items that may or may not be charged. In the chart below, we show what the U-tapes interacted with and what the result was, whether it was attracted or repulsive. We did 4 interactions with the U-tape, a subject's hand, a textbook, a pin that was ran through my hair, and another piece of U-tape. And we saw that as the subject's hand and the pen ran through the hair had a much stronger attraction than the other 2 interactions. And as we know, pin that's ran through the hair negatively charges the pen, which shows that with the attraction, the charge of the U-tape must be positive. So from there, we can determine that the subject's hand and the textbook were both negative or neutral. For data collection, the length of the tape was 0.2032 meters, and the mass of the tape was 2.032 times 10 to the negative 4th kilograms, and the distance between 2 floating pieces of tape was 0.00381 meters. With this information, we could determine the magnitude of the gravitational force, which was 0.002 newtons. And since we know that there is no net force, we can assume that the magnitude of the gravitational force is equal to the magnitude of the electric force. For the calculation portion, we use the electrical force equation and Coulomb's law to determine the charge of the piece tape. And since we know electrical force equals gravitational force, we can rewrite the equation as the following. By filling in the values, it was found that the charge of the tape was 1.793 times 10 to the negative 9th coulombs. And using this, we could find the excess charge by dividing the charge of 1 electron by the charge of the tape. That was found to be 1.121 times 10 to the 10th electrons. Continuing on with calculations, we need to determine the number of atoms that are giving up electrons. We did this by using the length of the tape divided by the diameter of the atoms, and we found 2.032 times 10 to the 9th atoms. We made a ratio based off this to find that for every 1 atom, there was 5.52 electrons in excess. We also had to assume that the tape was a point charge for this calculation, and we used the length, not the surface area, to determine the amount of atoms. We were asked a set of additional questions for this lab report. First being, what if electrons had positive charge and protons had negative charge? Well, if that was the case, the interactions would still be the same, due to the fact that charges would be the opposite of all the interactions, making them still either attract or repel. And the second question being, why is it important to handle the charged tapes as little as possible? It's important to handle the U-tapes with as little contact as possible due to the charge transfer from your hand to the tape, or vice versa, which could cause a weaker interaction. The electrons will transfer to a more neutral or positive environment. To conclude, we found the charge of the U-tape was positive with a charge of 1.793 times 10 to the negative 9th coulombs. And the ratio of the number of electrons in excess to the number of atoms on the sticky surface was found to be for every 1 atom, there is 5.52 electrons in excess. For the forces acting on the tape, they were found to be at equilibrium, making them equal to one another, which was an assumption made to determine the charge and excess electrons. As you can see in my code, I have the constants, the force calculations, the objects, and initial values to show the charge of the U-tape and the excess electrons. I also have coded the force diagram that's acting on the tape as a point charge. I have also listed in the comments the assumptions that were made in the lab protocol of ignoring air resistance and assuming that the charges between the 2 pieces of tape were the same for the force diagram. As seen in the diagram, the blue and green spheres represent the 2 U-tape point charges that are separated by their floating distance. The orange arrow is the electric force repelling away from the light charge, and the yellow arrow is the gravitational force acting upon the floating tape. The code prints the concluding values of the charge U tape as well as the excess amount of electrons.